Hi, my name is Ben Sly with Airframe Services in North Texas, located at North Texas Regional Airport at Perrin Field here in Denison, Texas. I maintain these A4s for Sky Resource Corporation, and they are managed by J.R. Starch at Legionnaire. I just kind of want to give you guys a walk around and give you a tour of the hangar. Excuse the mess, we have a lot going on. So. The TA4 here, it's not owned by us, but it's one of our good friends. This is a 146 Alpha Tango. We're in the process of doing a glass panel install on this aircraft. It's completely flyable except for the panel right now. We have a 147 and 207 over here. One thing that sets our aircraft apart from all the other A4s on the planet is ours are battery start. If you come around the side over here, you'll see we have two batteries in the hump. We'll remove the alternators and put a starter generator in their place. So these airplanes can fly anywhere and start unassisted, all by themselves. The TA, for instance, you need to have a huffer cart and a AC power cart on the ground to start it. This will start all by itself without anything. The start sequence takes a little bit longer, and they get a little bit hotter during the start, but they'll get up to about 650, 675 during the start, 720s max for EGT. I've been working on these airplanes since probably about 2006, 2008, somewhere in there. And it's 2019 now. We started off, actually, it was kind of a fluke. One of the A4 pilots came in and asked us if we wanted to do ejection seat modifications, sheet metal work. So I was like, well, sure, we need work. We don't know anything about it, but we need work. So they brung the airplanes in, and we converted them from the, I can't remember the old seats, but we converted them to 1G3 seats. And that involved cutting the aft pressure bulkhead out. We had to remove the fuselage tank, and we did a lot of sheet metal work behind the seat here. If you want to walk over here to one of the old aircraft that have not been modified yet, and I can kind of show you. These are how we got the aircraft in. They came in on the back of a truck. Fuselage, tail, engine, wing on its side, on a side of a flatbed, and we put them together. But if you look here, you notice this aft pressure bulkhead is flat. Okay, this is for the old style seat. The new style seat, the 1G3 seat, this has a bow in it for the rocket to fit, and this cavity's cut out for the firing mechanism. There's a couple paddles in there with M99 initiators, but that's how we got started with the ejection seats. Well, once we had the ejection seat sheet metal completed, then they said, okay, here's the explosives. Install them. I'm like, okay, give me some books. So they sent us all the manuals and everything. I said, okay, we can do this, no problem.
Did they have all the manuals on hand, or
they had them all on hand.
Really? Wow.
They had them all. So I was like, okay, this is no big deal. We can do this. So we installed all the explosives, got them all hot, and then they said, okay, let's make these things run now. And coming from a guy, I've worked on Learjets. That's all I did. I'm okay. I don't know anything about A4. Well, here's the manual. I was like, oh, read through the manuals. Okay, we can do this. And basically, I'm pretty much self-taught. Never been to school or anything for an A4. I'm sure a lot of people will say, man, you don't know anything, but I learned the hard way. I made mistakes and I've done things right, and we keep them running.
Now the zebra birds, did those used to be Draken birds?
No, they're always owned by A4L LLC, but they were leased to Draken, and Draken put the paint job on them.
Okay.
So they were always our birds, but
Gotcha.
they were leased to Draken, and Draken wanted their paint job on them.
Are these good airplanes to work on? Are they tough? Are they both?
They're pretty bulletproof. They're great aircraft. They're high maintenance. If I want to take this one outside and fly it right now, it can go fly, but I need 3 guys on it for about 3 or 4 hours to check all the oil levels, check the tires, check the struts, get it all ready to go. You know, versus a Learjet, just hop in it and go. Yeah, they're good airplanes. They're built rock solid. The thing about them is they leak. They use all MS fittings versus AN fittings.
Explain that, MS versus AN.
An AN fitting uses like a flare.
Okay.
Okay, on the tube, you flare the tube, and it fits onto. Here's an AN fitting right here. Okay, you see it's like a flare. MS fitting uses a ferrule. It's like a round collar that goes around the tube.
Oh.
Okay, and the problem with the MS fittings is if you tighten them too much, it cracks the fitting. An AN fitting, you can't really over tighten them. If it leaks, you crank it down tighter. An MS fitting, if you crank it down tighter, it cracks, and then you got to replace the fitting. So that's one of my biggest things I don't like about the A4 is everything's MS. As long as you don't over tighten them, they're fine. But you know, if you look on the ground here, they leak. That's what they do.
Marking its territory.
Yeah, right. That's just what they do. If they're it's like a Harley Davidson. If they're not leaking because they don't have any oil in them.
So these A4s, when they came in, they were just like this.
Right. The majority of these started over in Perryville at Saberliner, and that's where they were refurbished. And we did a couple of them here. We did this one and that one here. This is a 254 Alpha Tango, and that's a 146 Alpha Tango. We did those here. 254 is probably about 85% complete. Needs the engine to be installed and the cockpit to be completed. But it was painted here. You know, like I said, this airplane right here came in looking like that. You can see, you know, these aircraft, they originally had an alternator on the front of the engine. Big generator, it created 400 cycles AC. Now we use a starter generator that creates 24 volts DC, or 28 volts DC. So we need to generate AC current for AC power for all the equipment in the aircraft. So the way we do that is with rotary inverters in the hump. And if you look up here, you see that thing with the arrow on it?
Yeah.
That's a rotary inverter. There's 2 of those. One right next to each other. And that's what creates the AC. Since we no longer have an alternator on the front of the engine, we have to create it somehow.
And these are battery starts as well.
Yes.
Yes. Okay.
Yes. Now, if I was to do this differently, I would get rid of the rotary inverters and put static inverters in them. They're a little bigger, but they're lighter, and they don't draw much current at all unless they're under a load. These things, when they're running, the second you turn them on, it's 120 amps per inverter. So that kind of takes away from your starting power.
Is that harder on the starter or just longer on the sequence?
Longer on the sequence,
Okay.
because what you're doing, you're drawing more from the batteries.
Is that why they get hotter? Because of the longer start time?
The reason why they get hotter is because the starter generator doesn't spin them as fast as a air start.
Okay.
The
Gotcha.
air start probe. I have one over here. This is the probe that would start the A4 before we converted it to electric start.
That's cool.
And you had to plug this in. You had to have this thing. You plug it in the bottom of the airplane. Then you had to have a jet engine huffer cart to supply this thing with air. And you also had to have, well, not so much on the J65W20s, but on the J52s, you had to have a GPU to power up the igniters. Now the J65W20s, they have it's basically a magneto. So as the engine's spinning, it's turning a magneto that fires your igniters.
Gotcha.
So all you need for a J65W20 is the probe and a hover cart.
Okay.
All right, this here is a J65W20. It's not the most popular engine in the world. A lot of people don't like them, but it's a 40, 50-year-old engine and they still run. The biggest complaint I have about this engine is the oil vapor ducts. Here you have a 4-gallon oil tank, lubricates the engine. When the oil gets pumped to the turbine section, it dumps it overboard. You can see right here there's an oil vapor duct. It's covered up with aluminum foil. And over here there's the same thing, another oil vapor duct. Once the oil gets pumped in the turbine section, it dumps it overboard. So every time you run the aircraft, the airplane's an oily mess. It's horrible. And that's my biggest complaint about this engine. It works great. Very, very few problems with it. As opposed to J52, they don't have the oil vapor ducts. They recycle all the oil, but these don't. They dump it overboard. And EPA probably not real happy about that. But they're messy engines. This is the fuel dividers. This is, all around here you have all your fuel nozzles around the whole engine. I can't remember how many nozzles there are, but basically what you have here, you have your fuel control down here. You're pumping fuel up to the fuel dividers, and it's going to all your fuel nozzles. Like I said, your oil tank holds 4 gallons of oil. The limiting factor on flying a A4 with a J65W20 is not your fuel, because you can refuel in the air. You're going to run out of oil first, because like I said, you're dumping all that oil overboard. So on the bottom of the engine, there's a way to basically over-service the oil so you have it stacked full of oil. I think this thing burns about probably 2 quarts an hour of oil, and it holds 4 gallons. So you're limited by your oil and not your fuel, because you can refuel in the air. Down here, this is what I talked about earlier. This is your magneto. I call it magneto because it's, the engine turns it over, and it's a generator in itself, producing the electricity for your igniters. This right here, you'd have a hydraulic pump, and down below you have another hydraulic pump. This is your fuel pump here. The fuel control is not mounted on this engine or this one. I'll show you fuel control here in a minute. But it's a fairly simple engine. Right here is your oil pumps. You have 3 oil pumps, one for each section. One's for the front section, one's for the center, and one's for the turbine section. This here is the solenoid for your air start. And what it does, it adds fuel to your starting nozzles. which are by your igniters, which are here. Here's your igniter lead. Your igniter will go in this hole here, and this is your igniter nozzle. So basically what you're going to do is you're going to add more fuel. You're going to send electricity there to light that fuel, and that's going to light the whole ring. This engine here has a fuel control on it. Your FCU fuel control unit's here. That can be changed with the engine installed in the aircraft. If you look at the manual, it says, first thing it says, if you want to replace the fuel control, remove the tail, remove the engine. I've done this. It's not a fun job, but it can be done. This guy right here, there's a spring in here, and what that does, if you have a problem with your linkage to your throttle, it'll say your throttle cables break, it'll make your engine run at 86%. So basically, you can do whatever you can to get back on the ship. You can land at 86% throttle, and that's what the spring does. That's one of the tests we do when we trim an engine, make sure that thing works properly. The starter generators that we installed, they mount straight to the front of the engine here. Before it had a CSD, constant speed drive, with an alternator on it. We removed those and we put a starter generator there. So we cannot produce AC power off the engine anymore. We produce DC power, and that's why we have the rotary inverters on the hump. Here we have oil pressure transducer and oil pressure switch for instrumentation. This right here, the switch, if you see right here, we have two caps. We plug this into our jet cowl box to trim the engine, and that'll tell us RPM and EGT for when we trim the engine on the ground to make sure the engine's operating properly before we let it fly. Another thing that's different about these than a J65, than a J52, is, let's go around here to these nozzles. When we trim the engines, we basically adjust the EGT. We call these the turkey feathers. There's a clamp around this exhaust nozzle, and what it does is, say we run the engine at full throttle, full power, full mil, and the EGT is too low. Well, that basically means it's not producing the thrust it can. So what we'll do, we'll tighten this clamp around here, and it'll close down the exhaust nozzle, which will raise the EGT, but it'll also increase the thrust. The newer aircraft now, it's all computer controlled, and it's done with actuators and everything, and you don't worry about it. With these, we have to do it manually. So what we'll do, we'll take it out to the high power engine run up area, we'll tie the aircraft down, we'll go to full throttle, and we'll see what the EGT is. And if it's too low, we'll close it down. If it's too high, we'll open it up.
How big of adjustments do you do? Like a lot, or is it just a little bit here?
Usually it's like a turn or two on each side. Sometimes we have to do 2, 3, 4 turns, but it's not a lot. And it's crazy, is because all you're doing is closing this nozzle down a little bit, and it makes a big difference. Like if we're running at 103.6%, that's full mil, and the EGT is too low, it's closing that nozzle down to get the EGT up to where it's supposed to be for the temperature and barometric pressure of the day. It's exponential. We're talking 1,000 pounds of thrust. It's crazy. most of these planes were done in Perryville at Saberliner, but we had a couple that came in here basically in this condition. They showed up on the back of a semi truck, and when I saw them roll up, I was like, "Oh my God, what are we gonna do?" And they literally came in looking just like this. If you look over here, you can see the instrument panel is gone. Everything's gone. The ejection seats needed to be modded still. No engines. The engines came on the back of the truck as well. We have the tail over here. If you walk over here, here's the wings. And you can see all the wires were cut when they came out of the desert. They just chopped all the wires off. So we had to figure out where every wire went. But over, I don't know, maybe probably 3 months, we had the wing installed, all the wiring hooked back up. After about 6 months, we had the paint job done. You can look, this is a 154 Alpha Tango. And after about 6 months of work, we had this. The ejection seat mod was done. Aircraft was painted. All the new avionics were installed. You can see up in the hump where all the electric start equipment was installed. Where we installed the batteries, the inverters, rotary inverters. There's another inverter that gets mounted here on this panel. So it took some time. It took a lot of time, and like I said, when they first showed up, I was real skeptical. But we made it happen, and we came out with a bunch of good flying airplanes.
That's pretty amazing to go from that to this in 6 months.
Yeah,
That's impressive.
And actually 6 months is probably a long time. It probably didn't take us that long. We had a lot of guys working on it. You have guys that are used to working on Learjets all the time, and you bring an A4 in, and everyone's all work overtime. This is awesome. We're working on A4s. This is cool. So we didn't have a lack of work at all. They all loved it, and it was a lot of fun. It was something different.
Are there common things that, like, with some airplanes, this item will wear out, or that item will wear out, or this is always a problem, or that's always a problem?
Typically on an A4, it's mainly leaks. It's almost always a leak. Like I talked about earlier, the MS versus AN fittings. MS fittings are great, but you get guys that they're not familiar with them, and they over tighten them and they crack the fittings. We have these things, they're called Banjo Fittings. Let me see if I can find one here. Here's one right here. I don't know if you can see that right there. But that's a banjo fitting right there, and that's what cracks. If you over tighten that fitting, it'll crack that aluminum banjo every time. And I have bags of those things. And, we've been through 100 of those.
Just such an easy thing to break.
Yeah, they're just aluminum. Yeah, here's some here. Right there. Like I said, if you over tighten that nut, it'll crack that fitting right there, and it'll leak. And that's the biggest problem with these A4s is those.
Really?
And it's probably not a design problem. It's mostly a lack of experience problem. Something's leaking. Oh, tighten it more. That's not how that works on these. Don't tighten it more.
What's been the most rewarding thing for you being associated with these?
The most rewarding thing is seeing an aircraft come on the back of a semi-truck with bird poop all over it, and it's just horrible looking. it comes in and back of the semi truck, and you're like, oh my God, what am I going to do with that? And then watching it fly off. That's just amazing. I mean, right now I get goosebumps just thinking about that. Watching that thing fly off the deck is just awesome. I consider myself very lucky to have the opportunity to work on these. There's very few people that can say they worked on an A4, and I'm lucky to say I'm one of them. They're a lot of fun. They're very labor intensive. There's always something breaking, always. You're always fixing something, but they're great aircraft.
A lot of job security.
Yeah, a lot of job security, but they're great. I love them. It's like I said, not everyone gets to work on one of these. My bread and butter is work on Learjets, and it gets kind of mundane after a while. You do the same thing every day. You know what I'm saying? You tear the airplane down, they come in, X-ray them, you put it back together, fix all the problems, blah blah blah. But when you work on an A4, it's something different every single day. This is leaking, or this instrument quit working, or it's a challenge. It's very challenging to work on these things. I've never had any formal training on A4s, so basically I taught myself. They gave me the books and said, "Here, fix my airplane," and that's how I learned. And I'm very OCD and ADHD, so a challenge is good for me. I love it. It's a lot of fun.